Good afternoon. Uh, last week we started working on integer programming. Integer programming is a type of linear programming where we have only binary variables. We have kind of discrete values for our condition variable. For example, for the binary variable, for the binary case, we may have 1 or 0. For example, in a financial example, whether we decide to invest or not invest, higher or not higher, it has only two cases, all or nothing. For example, in an investment model, we cannot go halfway through and then change our mind, whether we invest the entire amount of kind of funding or not invest. So today we're going to use this model which is called integer programming. Which is a kind of subcategory of linear programming. Our decision variable can take on only limited values. For the binary case, it takes only 2 values. Okay? So we want to use this model, integer programming, to solve this problem. This is about kind of defining hub for the airlines. We have number of cities that cover the entire country. Okay? So here in this example, we have number of conditions. For example, if a city is located within 1,000 miles of another city, for example, Pittsburgh is located within 1,000 miles of New York, or New York or Philadelphia. Philadelphia can be as a hub for that city. So we try to use these conditions and find the minimum number of hubs for the entire country. We want to find the minimum number of hubs that can cover the entire areas in the United States. So our decision variable has to be a binary variable, whether a city is a hub or not, whether it can cover some other cities or not. So you need to open this file. This file, in the rows, we have the name of the cities, and on the columns, we have the name of the hub. Here, Atlanta means whether it can cover Atlanta, Chicago, and the other cities. One means it can cover that city. For example, Atlanta, I don't know what it stands for, CH. Let me check here. Atlanta, Boston, Chicago, Denver. Okay. So, for example, here Atlanta can cover Atlanta. Atlanta distance is more than 1,000 miles from Boston, so it cannot be used as a hub for Boston. One here means it can cover Chicago. Chicago. I'm not sure. So the columns are the name of the city, list of the cities that can work as a hub for the columns. So you need to determine whether we can have hub in these cities and find the minimum number of hubs for the airlines. So please open this example, 14.10, and try to solve this problem, which is very easy. And the name of the Excel file for this example is locating hubs. You can download it from chapter 14. It's a very simple example. You can get it done in less than 5 minutes.
So it's pretty close.
Yeah, pretty close. But okay, this is just an example. Okay, so as I said, Atlanta can cover some of these cities and it cannot cover the other cities. We have a binary logic, one yes or no. So we want to determine which cities to use as a hub to be able to find the minimum number of uh, hubs we want to minimize. And these kind of models are used in airlines. So first step, here is our decision variable. I'm going to color it orange. And I'm going to put some trial values, 0, and Excel will change these values later. So I'm going to define a name for this range for our decision variable. Oh. Select, we go to formula, create from selection. Left column is going to be the name of this variable. And according to this example, each city must be covered by at least one. Here, a city is covered if it is within 1,000 miles of at least one hub. So each city must be covered by at least one city. So for all these cities, we need at least one. And at least one. So it has to be bigger than or equal to 1. Here's one of our conditions. And for Atlanta, we can use, for example, some product of Atlanta row B6 through M6, B6 through M6 times our decision variable. Our decision variable is called used as hub. Used as hub. And we will copy this formula down for all these towns. And total hub is going to be the summation of this number of towns. Summation of used as a hub. We want to minimize this one. So total hub is going to be the objective variable. We want to minimize this objective variable. And we have two conditions. Now we have defined our variables. We connected all these variables with the decision variable. We can go to data, solver. The decision variable, objective variable is going to be total hubs, this one. We want to minimize this total hub. Decision variable is the used underline as underline hub question mark. What is this question mark? And we have, let me see. I probably misspelled something. Total underline hubs used as hub. Let's check the list of variables. Solver is very sensitive to typo errors. Oh. Total hubs. I didn't define name for total hubs. That's probably formula. Yeah, I didn't define total hubs as decision variable. So we select this, create from selection, and then we go to data, solver, total hubs, minimize, decision variable is the used underline as hub and the question mark. Now we can add our constraints. I should go ahead and define name for this too. Covered by, required, again we can go to solver and define our constraints. The first constraint is that covered underline by must be bigger than or equal to 1. What should be the next constraint? Our decision variable must be binary variable used underline as hub question mark must be binary. We need to select bin. Add, and now we have created our model. Total hubs, the objective variable. We want to minimize it. Decision variable is the use as hub. We have two constraints. Covered by must be bigger than or equal to 1. Used as hub should be binary. We check this box for non-negativity constraint. And from this drop-down menu, we need to select simplex linear programming. Solve. Let's see what we get. So these three cities, Atlanta, Boston, and I don't know what SL stands for.
St. Louis.
What?
Oh, it's St. Louis.
St. Louis. These three cities can cover all these cities in the United States. This way we can minimize the number of hubs to 3 and cover the entire town. This is one of the examples of kind of binary programming or integer programming. So we do not always need to have technical knowledge in different areas. Our job as a data analyst is to kind of find different data and to be able to connect this information. This interpretation is up to the subject matter expert. We can just do the data analysis. So the idea in this type of course is to familiarize you with different kind of example in human resource in different area of business, human resource inventory management, and this kind of planning, programming, so you can use these kind of skills in your future career. Do you guys have any questions? Thank you very much. That's all for today.